Good afternoon. Today we are going to see the first lecture, which is on ordinary differential equation. And in this lecture, we are going to study order and degree of ordinary differential equation. Now, first, what is ordinary differential equation? So an equation involving polynomials means terms of differentials or derivatives. So we have terms which are derivatives of dependent variable with respect to independent variable is called differential equation. Means if suppose y is dependent variable and x is independent variable, then we have terms like dy by dx, or we have term like d2y by dx square. So derivatives of dependent terms with respect to independent term. Y is dependent. Y is function of x. So y depends on value of x. So we are going to say x is independent variable and y is dependent variable on x. So if we have such terms, then that equation we are going to say as differential equation. Now we have two types in this. We have ordinary differential equation and we have partial differential equation. Now a differential equation in which dependent variable depends only on one independent variable is called ordinary differential equation. Means there I can say we have y is equal to f of x. Then we have u is equal to f of x. Means all dependent variables, you may have dependent variables 2, 3, but depends only on one independent variable. So independent variable we have only x. So we can have d2y by dx square plus d2y by dx, d2u by dx square equal to 0. So we have dependent variable is y, dependent variable u, but independent variable we have only x. So when we have independent variable is 1 and dependent variable are more than 1, that equation we are going to say as ordinary differential equation. So this is first type. Then we have second type, that is partial differential equation. So in which dependent variables, here may be variables or variable. It may be variables or variable, depends on one or more independent variables. It's called partial differential equation. So we have dabba square u by dabba x square. So u depends on x plus dabba square v upon dabba y square. So we have here x depends on u, v depends on y. We can have dabba square w divided by dabba x dabba y. So we have dependent variable u, v, w, and this dependent variable depends on independent variable. U depends on x, v depends on y, w depends on both x and y. So we have both dependent variables are also more than one and dependent variables are also more than one. Then equation is known as partial differential equation. Then we are interested with ordinary differential equation. So you can see over here. So in this equation, we have y as dependent variable and x as independent variable. So in whole, you can see we are being with only y and x. And then we are going to say this equation is ordinary differential equation. We can have another also du by dx plus x into du by dx equal to u. Again, independent variable is 1, that is x. So whenever we are with one dependent variable, then that equation is known as ordinary differential equation. Then we have partial differential equation. You can see over here, we have dependent variable is u, but this u depends on x also, and u, which is dependent variable, also depends on y. So u is function of x and y. And when one dependent variable is function of more than one independent variable, then the equation formed is known as partial differential equation. Then you can see d cube u by dx cube plus d square u by dy square. So sin y. So likewise, we have this equation which are related with partial differential equation. Because when we will go third part of this GATE syllabus where we have partial differential equation. Now we have the order. Order of a differential equation is defined as the order of the highest order derivative. So order is highest order derivative in the differential equation. That we are going to say as order of a differential equation. Suppose I will write d4y by dx4 plus dy by dx cube plus d2y by dx to the power 4 d2y by dx square to the power 4, and that is equal to 0. So highest order of derivative. Now order of derivative of this is 1 because we have dy. Once we have to take derivative. Now order of this derivative, we have to take derivative twice. Dy by dx, and again we have to go for this, though this is 4, but order is 2. And then here we have order 4. So here I have order 2. Here I have order 4. And then highest order derivative. So we have 4. So we have order of this equation is 4. Likewise, we have to find order of the differential equation. Now we will go with degree. The degree of differential equation is the power of the highest order derivative. So just we have written this d4y by dx4 plus dy by dx to the power 4 plus d2y by dx square to the power 5, and that is equal to x4. So now what is degree? So now first we have to find order and degree or power of that order we are going to say as degree. So now we have this is to the power 1, and order we have 1 over order over here we have 2, and order where here we have 4. So highest order we have 4. We have to take power of this, and power is 1. So if I will say this equation, I have order as 4 and I have degree as 1. So likewise, we have to find order and degree of the differential equation. So now we will solve some problems. So we have the order and degree of the differential equation given below. Now you can see this. In this, we have order, this is highest 2. And now if I will mention power of this, so we have power 1. Now order of this is 1. Degree is also 1. So we have this is 2. So degree or power of highest order. So we have 2 as order and 1 as degree. So we have order is 2 and its degree is 1. So now we will go to the next. So we have cube root of 1 plus dy by dx cube is equal to d2y by dx square. Now when we are going to find out degree, we should be very clear. We do not have any fraction as power. Fraction as power is not allowed. As power should not be in the equation. Should not be there. Any derivative should not be transcend, means We should not have sine dy by dx. We should not have log dy by dx. If we have likewise, we cannot define degree. We cannot define degree. If we have power negative, then also we cannot define degree. So if we are in this way in the equation, then power cannot be defined. Power cannot be defined. So we should be very clear with this. Now you can see we have this is cube root. Means if I will write it as 1 plus dy by dx to the power 3, and then we have this as 1 by 3, and which is equal to d2y by dx square. Now I will go for cube on both sides, and taking cube, what we will get? So we have 1 plus dy by dx to the power 3, which is equal to d2y by dx square to the power 3. Now we have order of dy by dx is 1, order of d2y by dx is 2. So highest order is 2, and then we have to see its power. So we have 3. So we have order 2, and then we have degree 3. So likewise, we have to solve the problems. You should be very clear with this. We are going to be first determine the values, or we are going to remove these fractions, or if we have negative powers, and then we will solve it. And if we cannot remove this, then we are going to say degree, or I can say instead of power, we are going to say power negative, or I can say that is power means I am going to say here dy by dx, and its power is -1. Or I can say 1 upon dy by dx. So its power is -1. So if this power is minus, then we are going to say degree cannot be defined. Degree cannot be defined. So here I will say order we have 2 and degree we have 3. Then we have like this. Now, as I just mentioned it, we cannot go negative power. And then if you will solve this, then we have this as dy by dx equal to 2 sine x plus 3. And if you will take it in numerator, then we have dy by dx to the power -1. So this now minus cannot allow, is not allowed, or if minus is there, we cannot find degree. We will take it on this side. So we have dy by dx to the power 2, and that is equal to 2 sine x plus 3. Now you can see we have order 1 because we have 1 dy by dx 1 1, and then this will be degree. So degree is 2 and order is 1. So we have 1 and 2. Then we can have the degree, order and the degree of the differential equation. Now you can see, I just mentioned it. We should not have fraction. So now we have to take square of this. So what I will get d2y by dx square plus dy by dx plus x, and then we have to the power 2, and that is equal to 1 plus d cube y by dx cube. And now we have order 2. We have order 2, and here I have order 3. So order of the derivative I am mentioning. So order of this differential equation, we have 3. And then what is its power? So we have 1. So I have this 3 as order and 1 as degree. So we have answer is 3 and 1. Then we have the order of the differential equation given below. Now here directly we can have, so you can see this. we have order or power of derivative is 2. Here we have 1. And therefore we have to consider power of this. So we have 1. So we have order as 2 and degree as 1. Then this we can have. So triple dash, what does it mean? So it means we have d cube y by dx cube, third derivative, whole square, plus 3 times d2y by dx square plus 3x dy by dx and plus 5y, and that is equal to 0. And therefore we have highest derivative, we have this 3 because this is 2, this is 1, and here we have only dependent variable, and therefore we have 3 will be order and degree will be 2. So order will be 3 and degree will be 2. Now here the order, again we are going to say highest power. So here we have highest derivative 2. Here we have 1. So we have order is 2. Now degree. So we can have here 2, but if you will see, we have this transcend, that is cos. And in that case, we cannot define degree. So whenever we have log, we have transcend, we have in this way or negative power or we have fraction, in that case we cannot define degree. So we have order 2 but degree is not undefined. Then we have the order of the differential equation. Now you can see we have 1 plus dy by dx whole square to the power 3 by 2. Now this is fraction. So I will multiply both sides by 2, or I will take it twice square. So I will get it as 1 plus 1 up dy by dx. We have 3 by 2 into 2, and that is equal to 8 into d2y by dx square, and that is to the power 2. So now this 2 gets cancelled. So we have order of derivative is 1 and order of derivative is 2. So order I have 2, and then we have to find power of highest order of the derivative. So this is 2. So this becomes your degree. This becomes your order. So order is 2. Degree is also 2. Then in this we have, you can see now we have fractions for both 1 by 2, 1 by 3. And now we have to go for natural numbers. Then I can have this as d cube y by dx cube. Now when we will have like this, we have to go for the LCM, and we have this will be 3 into 2, that will be 6. We will not go for upper part, we are interested with bottom only. 3 into 2 6. So I will have 6 upon 2 minus dy by dx 6 upon 3, which is equal to 20. And then from this we will get it as d cube y by dx cube, that is power 3 minus dy by dx to the power 2 equal to 20. And then we have order will be 3. This is my order. And degree I can have of this only. So degree also I have 3. So we have both degree and order, both are 3. Then we have this equation. Here we have, again we have to go for square of this. So what I will get, x plus d2y by dx square whole square equal to 1 plus d2y by dx square whole square. Then we have square of this x square, because we have d2y by dx square on both sides. So we have to check it. So x square plus 2x d2y by dx square plus d2y by dx square whole square, and which is equal to 1 plus d2y by dx square whole square, and this whole square gets cancelled, and we will have now order as 2 and degree is 1. So do not fast. So here you cannot say we have that is root we will take outside, then it will be 2. Likewise, you have to solve and then you have to decide. So I have order is 2, but degree is 1. So I have this as degree, I have this as order. Then we have this question which was asked in 2010. So now in this, we have to take actually this part on left side. So we will take this part on left side. So we will have this part. And then as we have this as root, so we are going to make square on both sides. Now this root and this square gets cancelled. Minus 4 square becomes 16. And then we are going to get it as d cube y by dx cube square, 16 dy by dx cube plus y square. Now here you can see we have order or power highest of derivative is here 3, and then degree of this we have which is 2. So we have order 3 and degree 2, and then we have this will be last question. So you can have simple question was asked in 2007. So we have order 2 and power of this bracket is 1. So we have order 2 and degree 1. So likewise we have to solve the problems which are related with your differential equation, and that is order and degree. So now we will stop here only. Next part we will see in next video. So thank you.